All right, so the rest of this chapter and our rest of this course pretty much has a lot of what I'll call plug and chug type of problems. So the main equation here that we're going to learn about is Q equals mc delta T, right? Where Q is heat in joules, m is mass, usually in grams, C is specific heat capacity in units of joules per gram degree Celsius, and then delta T is the change in temperature. It's equal to T final minus T initial, usually given in degrees Celsius. And so we can formulate all kinds of different problems where I give you some of the variables and then ask for a remaining variable. We can only ever solve for one unknown variable, so you always have to be given all the other variables. So just as an example problem, 1.23 kilograms of iron at 25 degrees Celsius is heated with 823 joules of energy. If iron has a specific heat capacity of 0.449 joules per gram degree Celsius, what is the temperature of the metal at the end? And so plug and chug type of questions generally follow the same format. Whoops. The first thing you want to do is you want to identify what kind of equation you want to use. Right, obviously, since this video has it in the front, that's the equation that we're going to use. Q equals mc delta T, which can also be written as Q equals mc TF minus TI in parentheses. The second thing that you want to do is you want to identify the unknown. Which part of this equation are you going to solve for? In this case, we're asked for the temperature of the metal at the end. So what we want is TF. Once we know what we want to solve for, you want to rearrange the equation to isolate the unknown. So in this case, what we do is we divide both sides by mc, and then we add Ti to both sides. And then that'll give us the equation of TF is equal to Q over mc plus Ti. And then finally, the fourth step is to plug and chug. So plug in your variables, type it into your calculator, and see what you get. Always be careful for the units. Make sure your units can communicate with one another and that they can cancel out when they need to. So for example, let's go up to the question. We see that first we want Q. So Q is the amount of heat. So it's 823 joules. Next up, we've got the mass of the metal, which we have as 1.23 kilograms. However, we know that mass is generally given in grams, and our specific heat here will be in grams. So we need to convert those kilograms into grams. So we have 1.23 kilograms. For every 1 kilogram, you've got 1,000 grams. So you end up with 1,230 grams. Plug that into there. Next up, we've got our C, our specific heat capacity, which is given in 0.449 joules per gram degree Celsius. And then finally, we have plus our TI, which is our initial temperature. And we can see that we started at 25 degrees Celsius. Let's change that up to 25.0 degrees Celsius. After that, you just want to plug in your calculator, but of course you want to make sure that all your units can cancel out when they should, right? So joules and joules can cancel out here, right? If we were given 1 unit in kilojoules, we need to convert it back to joules. And then grams and grams cancel out here. And that's good that they cancel out, because if we just plugged in 1.23, we would have gotten the wrong answer, but we checked our units and made sure that they canceled out. And then you can see we'll be left with degrees Celsius plus degrees Celsius, so that's totally fine. And then plug that into your calculator. You should get about 26.5 degrees Celsius as your final temperature. So again, be comfortable with these plugging and chugging type of questions. You're going to see a lot of them. Of course, the key, as always, is to practice.